So 11 and 12, because the definition really comes, or I think is linked into the formula. So I think it makes sense to present both together. So H dot is this new idea then, equivalent dose rate and a rate of anything in physics means how much of that you get per unit of time. Now the unit of time can vary, so sometimes we're looking at how much dose you've received per day, per hour, per year. Okay, so the units can vary quite a lot. Right, it's not the kind of standard per second, because usually those values are very, very small. So the units might be sieverts per hour, sieverts per day, or sieverts per year. Although in reality it will tend to be millisieverts. So H is the equivalent dose. Oops, sorry. Equivalent dose measured in sieverts, and T is the time, which could be measured in hours, days, or years. So a worked example. If you had a dentist performing medical x-rays, let's say that they do 8 dental x-rays in one day. And each contributes an equivalent dose of 7 microsieverts, and the day lasts 8 hours. Calculate the equivalent dose rate in sieverts per hour. So we've got a wee bit of work to do, in that we're not just given the equivalent dose, we're told that there's 8 of these x-rays and each of them contributes 7 microsieverts, which gives us a total of 56 microsieverts. The day lasts 8 hours, and we're being asked H dot, the equivalent dose rate. So the equation is H dot equals H over T, and we substitute in our values. I'm just keeping it in microsieverts for just now. I could convert, I will do in a wee second. The reason I have to convert is this question specifically asks for the answer in sieverts per hour. If it didn't, I could have just left it as microsieverts per hour, 7 microsieverts per hour. But micro, remember, is 10 to the minus 6, so to convert to sieverts per hour, we just put in that prefix, micro is 10 to the minus 6, and that's our answer. So 13 is compare equivalent dose due to a variety of sources. So examples of equivalent dose. And I'm going to split these into 2 headings, right? Looking at natural and artificial. Okay. So some examples of natural: 100 grams of Brazil nuts. Right, and that was 0.01 millisieverts. Other natural ones, well, radon gas, the UK average. So quite significantly higher. Some examples for artificial though, well, a dental x-ray. And we're just keeping everything in millisieverts. So we can easily compare them. So 0.005 millisieverts. A CT scan of your head would be about 1.4 millisieverts. So that's not an everyday thing, right? Not many people will get a CT scan in any given year. So it's just trying to show you, and even if they do, that's kind of similar to the levels we get from radon gas in a year anyway. So it's really just to be able to compare those different values for learning outcome 13. For learning outcome 14, then these are the values which you need to memorize, right? And that is average background radiation in the UK. And that is 2.7 millisieverts. And then on top of that, you have limits for workers in the nuclear industry. And basically we reckon you can get up to an additional 20 millisieverts without a significant effect on your health. But the nuclear industry is much more controlled in terms of how much it can expose members of the public to. Right? So there's a lot of measurement done round about, say, a nuclear power station to check, right, that the limit to the public by the nuclear industry shouldn't exceed 1 millisievert on top of the normal background radiation.